Hi everyone, I'm Ester Gonzalez from Nokia Labs, and I'm here to present the work entitled Egocentric Human Segmentation for Mixed Reality, which has been done in collaboration with Universidad Autónoma de Madrid. Egocentric perception has become an important topic in mixed reality since the incorporation of egocentric cameras to virtual reality headsets, as you can see in the picture. Augmented virtuality in particular is one of the subcategories of mixed reality that combines items from the local reality surrounding the user with an immersive environment. There are many advantages related. For instance, if we focus on segmenting user body parts, the sense of presence is increased. This idea is very powerful and might create very interesting applications, such as allowing yourself to eat sushi in the beach rather than in your office. Let's see this example. In this application, there is a combination of a 360-degree video with certain portions of the local reality, in this case, the user's hands and certain food items. In the context of segmentation approaches for augmented virtuality, there have been two main methods in the literature. The method used in the previous video was based on color, allowing to segment hands from their skin color. And that has the advantage of being very computational light, but also it constrains the environment appearance. There are also methods that are based on depth. However, they are still very noisy and there is no full control on the object to be segmented. In our previous work, we decided to use deep learning networks to target this segmentation problem. We moved the concept from hand to arm segmentation. We applied transfer learning to one of the state-of-the-art semantic segmentation networks and got results much more robust than color-based. However, this architecture could not meet real-time requirements, which is very important for mixed reality. Also, it could not segment the entire egocentric body. That's why we decided to target the problem of egocentric human segmentation. Due to the lack of egocentric human dataset with pixel-wide labeling, we have created a semisynthetic dataset by acquiring foreground and background independently, and therefore easing the labeling task. You can see more details on our paper. Alpha matching algorithm was used to get a more realistic blending between foreground and background. As a result, we built the egocentric human segmentation dataset with pixel-wide labeling in 3 different positions, with more than 15,000 images. We decided to use the standard net architecture since it reported the highest frame rate. Also, its architecture was based on very standard modules, RaiseNet 18 for the encoding, pyramid pooling module for extracting features at different scales, and a decoding subnetwork made of some deconvolutional and upsampling layers. In order to adapt better for our problem, we increase the filter size of the pyramid pooling modules and include long skip connection between encoding and decoding part. Also, in order to tackle class imbalance, we employ weighted cross entropy. We divided the dataset into training and validation with disjoint users. Also, we use some standard egocentric hand dataset for evaluation. As there are no datasets related to the entire egocentric body, we also recorded some videos for qualitative assessment. This table reports the result achieved with our previous work and the new shallower architecture. As can be seen, results are comparable with the deeper DeepLab version 3 architecture. However, the big benefit here is the high boost of frame rate that we achieved with this new architecture, concretely increasing from 15 frames per second up to 62 frames per second. Also, you can hear see some qualitative examples from those frames. Let's also see some videos. As you can see, the quality of the segmentation from the human body is quite reasonable, but we experience an arise of false positives coming from the background. We hypothesize that this has to do with the unlimited variability of the backgrounds, which cannot be retained with the network parameters. As to sum up, we have built in this work an egocentric human segmentation system that targets real-time requirements. We have also created an egocentric human segmentation dataset that is going to be available for research purposes. However, we still experience an open problem, which is related to the false positive coming from the background. For future work, we are also planning to include death information in a multimodal egocentric deep segmentation network. So thank you very much for your attention. For further discussion, you can contact me via email. So stay safe and greeting from Spain.